Now it's recording. Yeah, let me repeat. I designed the quiz in such a way so that you would pay enough attention to the book's examples and our class examples and definitions. Otherwise, according to my previous experience, many of you would not review the examples or definitions we did in class. That's not good, okay? So another question, another point I want to make is that we do have a second project coming. I signed the second project yesterday already. It is due 2 weeks after today. Okay, 2 weeks after today. That's the due date for the second project. Let me share the screen. So if you click on assignment, you should be able to see everything you needed to do. Look, the second project is due March the 12th. Okay, if you click on it, you should be able to see the PDF of the second project. And I think this project is kind of easier than the first one. As a friendly reminder, don't delay things to the last moment. Please start working as early as possible, okay? So with that said, does anyone has any question before we start on the lecture?
I have a question about the quiz for today.
Yes.
What chapters is it going over?
I hope you have saw my email. Let me show you the email. Yeah. So this email I sent to you yesterday. In the email, I said covering section 7.7, 7.8. That's it. Okay. Did I answer your question?
Yes, thank you.
Thank you for asking. By the way, a general rule is that we are always covering what we did in the previous week so that you would have enough time to do the review, to study the material before the quiz, okay? As always, we are covering what we learned in the previous week. Okay, any more questions before we start? So let's start. Now we are on the document camera. For this section, we are learning the inverse trigonometric functions. Continued. For it, section 8.1, we learned the inverse sine, inverse cosine, inverse tangent, right? We did 3 already. However, we still have another 3, which are inverse secant, inverse cosecant, and inverse cotangent. As you can imagine, those functions are a little bit more complex than the sine, cosine, tangent stuff. But still the same rule applies. Okay. As always, this question is just a review what we did in the previous class to warm you up. Notice we are still doing inverse tangent, inverse sine. Okay, we have not reached the inverse secant yet. So let's review what is the inverse function. if you have an angle, you take a sine of it, you reach a value, right? If you take the inverse of that value, you are mapping back. It is equivalent with, if I give you a y, what is the angle corresponding to it if you map back by a sine? Inverse sine, okay? So inverse function, just a way to find the angle behind the value. For example, tangent. If you have an angle, tangent of this angle mapped to 1/2. What is inverse tangent 1/2? Inverse tangent 1/2 is just the angle which can create this guy. So look at here. This looks complex, sine inverse tangent stuff. But in your mind, whenever you see an inverse trigonometric function, you should always think it as an angle. Okay, this is always an angle. You're looking for an angle which, using the tangent function, we can map to the value here, which is 1/2. Inverse tangent map back. Okay, this is a review what we did. So how can we find this angle? Finding the angle, you have to create a imaginary triangle. Okay, so tangent of this angle, you got 1/2. So this, if this side is 1, this side is 2, right? Just create everything according to the proportion. Tangent theta is 1/2. So let's just say this side is 1, this side is 2. So what is this side? Can anyone tell me what's this side? I'm afraid not. Someone says 3. This side is not 3. So let's use the Pythagorean theorem to figure out what's the side on this one. This side, let's say, is c. So c squared equal to 1 squared plus 2 squared, right? This c is hypotenuse. Oh, so c squared is 1 squared plus 4 squared of plus 4, which is 5. C squared is 5. So c is square root of 5. Okay. So after we create such a triangle, we figure out this side is square root of 5. Then let's look at sine theta. Theta is here. So what is sine theta? It's just the opposite side divided by the hypotenuse, right? Sine theta is 1 over square root of 5. That's it. That's our final answer. After we write this is our new theta, we create such a triangle. Then starting from this triangle, find the angle, find every side. Then we can know the sine value of this angle. Okay, is that clear for this question, how we get 1 over square root 5? Okay, cool. So this is just a warm up. We're still doing sine inverse tangent stuff, which is section 8.1. Let's go to the main topic today. Inverse second. Inverse second. That is making me feel very nervous. What is inverse second? Again, every time you have a theta, second of it, you map to your value, right? It's defined exactly the same way as we did for sine, cosine, tangent. So inverse second map back from the value to the angle. Okay? So in your eyes, this is always an angle. Always an angle. Okay. But we encounter an issue. What is the domain of this function? What is the range of this function? So in order to figure out the domain and the range of this function, we need to think about what values y can take. Okay. Now, since we're inversing second, those y values becomes the domain. This angle becomes the range. This is still confusing. So what values can y take? We don't know, but let me tell you an easy trick. We can just read from the graph. I open Desmos and I read the and I show you where the y can take values. This is our second function, right? This is just our second function. When we are looking at y, this will become our new domain since we're using the inverse second. So do you guys see something pattern where y can take values? Okay, it may look very difficult, but let me just tell you the answer. Y can take any value which is greater or equal to 1, right? Look, smallest value is 1, any value greater or equal to 1. Or it can take any value smaller or equal to -1. Okay, either greater or equal to +1 or smaller or equal to the -1. That's where y can take values. Again, our y values becomes the domain. So let's go back to the document camera. So what our domain will be? +1, -1. So this is where y can take values. And the previous y values now in our new inverse second function becomes the domain. So our domain is -infinity to -1 bracket union +1 to +infinity. Any question on how we get that? Just think about this graph. Okay, any question on this part? Okay, so let's look at where the range is. Range is where this theta can take values. But here is the issue. We restrict our theta to be somewhere. We're not using all the theta. We want to be 1 to 1. In the previous class, we want the inverse function to be 1 to 1 so that we restrict it to only part of the angle, right? For example, for the sine theta, for the inverse sine theta, sine x, it restricted itself to negative pi over 2 to positive pi over 2, right? And oh, sorry, this is a range. The domain is negative 1 to 1. The new range after such a restriction is negative pi over 2 to positive pi over 2, right? This is for inverse sine, domain range. So what is our values here after such a restriction? Okay, I'll give you 1 minute to think about it. Think about this graph just for 1 minute. Since we're doing the first one, I would like you guys to think about it. Then for other inverse functions, they are done exactly in the same way. 1 minute to think about it. Feel free to voice any of your opinion.
This is for the graph that we just saw, right? The secant?
Yes, let me show you the graph again. Okay, we restricted the inverse function so that it is 1 to 1. Think about where should we restrict it. Think about it and think about what I write down on the paper.
I mean, I could take a guess. Could we go from negative pi to, you wouldn't go to pi again, would you?
You cannot go to pi. That will be too big.
So then would it be negative pi back to 0?
That's a very good guess. That's a very good guess. However, I would say our final answer is different. Okay. So thank you for trying. So I know this might be a very confusing question. So let's look at the other function to give you an idea. Okay, this is my hint. Why do I type in inverse cosine? And cosine. What's the relationship between inverse cosine and cosine with secant? Okay, I know. This might be the most challenging question ever since the start of this semester. So let me just directly tell you why I write down inverse cosine. So this is just my scratch paper. This has to do something with the definition of second function, okay? So this second function, by definition, is 1 over cosine x, right? So this is how they are related. In order to figure out the range for for the inverse second, you should see where the x can take values so that it is 1 to 1. In order to find where these take values, a good hint is where we restrict the cosine so that it is 1 to 1. Okay. Where we restrict the cosine so that it is 1 to 1 is the same area with where we restrict second x so that it's 1 to 1, because they do have a 1 to 1 relationship here. Okay. So this is just a rough sketch. In our previous class, we restrict our cosine from 0 to pi, right? We restrict it here so that you can see it is 1 to 1. This is what we did for our cosine. We get 90% of the answer already. It's just the same area we restrict with cosine, 0 to pi. But check this equation again. We are doing with second function. There is something different. For cosine x, now it's in the bottom of the fraction. So there is one additional restriction. For a fraction, the bottom part cannot be 0. Okay, so this guy cannot be 0. So as you can see, this is a bad point. So we must remove this point. So this point is pi over 2. That's where cosine pi over 2 is 0. This is a bad point. We should remove pi over 2. So the range is 0 to pi. However, we need to remove pi over 2. So how about we do this? 0 to pi over 2, parentheses, union pi over 2 to pi, bracket. That's it. That's our range. I know this might be the most confusing part of this lecture, how we get the range. Let me repeat the key idea. Because we have such a relationship between secant and cosecant, we use the same area where the inverse cosine is 1 to 1. We figure out when the cosine x restricted from 0 to pi, it is 1 to 1. So we use the same area as cosine, okay? However, for the definition of a second function is 1 over cosine. So there is additional one requirement. The bottom part of the fraction cannot be 0. So this point is a bad point. You have to remove this point. That's why you are using 0 to pi over 2 processes to exclude this pi over 2, union pi over 2 to pi, bracket. Okay. Anyone has any question? Feel free to ask.
Are we going to be graphing the inverse of secant?
I don't think so. I don't think you need to graph that. So all we do for this class, we figure out the definition of the inverse secant and the inverse cosecant. We understand what do they mean and figure out the domain and range of them. I think that's it for this class. Oh yeah, we also need to plug them into the calculator. Plug them into a calculator. And that's it. Anyone has any question? Okay. So the first one is kind of slow. For this one is kind of faster. We're using the same approach. Let me just draw the same picture. Theta, this angle, cosecant, you map to your y value, inverse cosecant, you map value back. However, again, in order to figure out the domain and range, what is a cosecant defined? How it is defined? It's 1 over psi. So where we restrict sine, we use the same area to restrict cosecant. Before doing that, again, let's repeat the same process. Let's see the graph of the cosecant function. Wow, this is very, very similar with the second function. So right now, the y values can take greater or equal to 1 or smaller or equal to 1. This is cosecant function. Y values can take those values. So for the domain of inverse cosecant, it's just the same as the range of the cosecant. So our new domain is the same as the previous range. Let me switch to the document camera. Our new domain is still the same with the previous range. That's it. What is the range? Again, it is where we restrict sine so that it is one-to-one function. Where did we restrict sine? I write down here, that's my hint. We restrict it from this angle to this angle. Okay, so that's our range. Our new range is just where we previously restricted our sine. This is our sine function. Apologize. Just a very rough sketch. I know it looks like agony. We restrict from negative pi over 2 to pi over 2, right? So that is 1-to-1. The previous domain now becomes our range. So it's just negative pi over 2 to positive pi over 2. That's it. Any question on this one? We just follow the same steps as we did for the first one, just in a faster pace. Okay. Okay, let me repeat the key idea. Inverse cosecant map from the value back to the angle. To see where the domain is, we need to figure out where the values can be. And according to our Desmos graph, the values can only be in this area. Okay, from negative infinity to negative 1, union positive infinity to positive 1 to positive infinity. And in order to figure out where the range is, we need to figure out where the domain for the inverse sine is, because there is such a relationship between cosecant and sine. Remember, we previously restricted our sine from here to here. So this was our previous domain. Now under the new inverse function, it becomes the range. Okay, That's it. Any question before we move on? Okay, so let's continue. We do exactly the same thing for inverse cotangent. Cotangent map an angle to a value, inverse cotangent map back. And in order to figure out the domain, let's see the range or where the y can take values. Again, let's check the decimals. So this is our cotangent function, where the y can take values. It's everywhere, right? Everywhere from positive infinity to negative infinity. Y can take every value on the y-axis, right? Okay, someone type me something, let me see. So our domain is just everywhere from negative infinity to positive infinity. Under this new inverse function, these y values become the domain, and then we just check on the decimals. The domain is everywhere. How about the range?
I'm assuming it would be restricted the same way as
Very
like
good.
secant and cosecant.
Very good. It is restricted the same way as cotangent in order to be 1-to-1. However, again, let me write this fraction. By the definition, cotangent x is just 1 over tangent x. So it's just where tangent x is restricted. The tangent x, we did some graph like this before, right? It's restricted from here, pi over 2 to pi over 2. But there's the issue. It can never take pi over 2. This was because tangent x is also a fraction. It's sine over cosine, right? If you take x to be pi over 2, cosine of it is just 0. This fraction is hugely wrong. You got something over 0, which is not good. So it can never take pi over 2 or negative pi over 2. Just what I said, restricting the same way. However, you remove the bad points. So it is negative pi over 2 to pi over 2. That's it. Anyone has any question? That's a hard part of today's class, really.
Actually, I do have a question, Professor.
Yes,
so
please.
why? So we can have it as 0 as well. So like if like when tangent of x is equal to 0, like right at the origin, that still works because it's 0 over 1, right? If you look at it that way.
Let me think about it. Oh, I think I made a mistake, by the way. Let me share the screen and tell you where my mistake is. Well, thank you, Ernesto, for pointing that out. So this is a cotangent function. It's different from the 1 over tangent x. So they become different. In order to make a reverse possible, look at the graph. We should find a segment where it is 1 to 1, right? And my mistake is that I picked the wrong segment of the graph. So if you would have to pick a segment, in order for it to be 1 to 1, you would pick from somewhere from 0 to somewhere here, right? So from here to here, it is 1 to 1. And what is this point, by the way? You see this line is approaching to.
That should be pi.
Yes, pi. Okay, that's where my mistake is. I restricted on the wrong area. I said it's negative pi over 2 to pi over 2. As you can see, from here to here, there is some kind of overlap. For example, this has 0, this also has 0. If you remove them, you will have two broken parts. We want an integral part, a complete part. So that's where my mistake is. Okay, go back to the next notes. If we restrict from 0 to pi, it's become 1 to 1. Okay, just forget about what I write on here. That is my mistake. Okay, thank you very much for pointing that out. And does anyone has any question? Okay, so let me repeat the key idea. Cotangent map from angle to value, inverse cotangent map from the value back to the angle. And we want to find an area where it is restricted so that it is 1 to 1. However, according to our Desmos graph, the best area we restrict ourselves from 0 to pi. Okay, so that this is a complete part. This is 1 to 1. So previously I said from negative pi over 2 to pi over 2, that will become two parts. And they have an overlap, which is here, 0. That is not good. So we want something simple and complete. So it's best for us to restrict ourselves from 0 to pi. And it can never take 0 because it's getting extremely high, and never take pi because it gets extremely low. Okay, so that's why I'm writing 0 to pi processes to exclude the two endpoints. That's the key points. So let's continue. Now comes the easy part of this class. According to my feeling, is the easy part. Find the exact value of those angle. As always, those are just angle. Always think about it in this way. This is just angle. This is just angle. Okay. This angle, what can we say about this angle? If you have a theta, cosecant theta map to that value 2. Inverse cosecant map back to the angle, right? So we have such a relationship. Cosecant theta equal to 2. That's our relationship. And again, cosecant theta is just 1 over sine theta. 2 equal to 1 over sine theta. So sine theta should be 1 over 2 if you just flip both sides. So what is the angle of this guy? this angle is just theta equal to inverse sine 1/2. So what kind of value satisfies this relationship? Let me draw another graph. So theta, this angle after sine it mapped to 1/2. Can anyone tell me what kind of angle this is? Sine this angle could give you 1/2.
Would it be pi over 6?
Very good. It's just pi over 6. Okay, we encountered this value many times in this class already. That's it for this question. Again, for a second question, you will ask the second this angle. What would it be? This angle be? We do not know, but we do know theta after this sine gives you -1/2. So the angle is inverse sine -1/2. Can anyone tell me what is the angle which sine theta equal to -1/2? There should be such an angle.
Is it 11 pi over 6?
It is -pi/6, right?
Oh, it's -pi over 6. Okay.
Sine -pi/6. Because our sine pi/6 is 1/2, our sine -pi/6 is -1/2. Okay. Or you can use a graph to help you to think about it. This is our sine function, right? So if you have theta equal to pi/6, you get this value. Then the negative part, you get a negative value of it. So this angle we figure out is -pi/6. So what is second that value? Again, second function is complex. Let's break it into small parts. A second function is just 1 over cosine. This value. And according to our unit circle, if you have a -pi/6, it still uses the same x coordinate with pi/6. Sorry, this is not a unit circle. This looks so stretched out. But just think of it as a unit circle. And the cosine value of it just depends on the x coordinate of the terminal point, right? So pi/6 and -pi/6, they have the same x coordinate. So this is equal to cosine pi/6. Can anyone tell me what is cosine pi/6?
Isn't that square root of 3 over 2?
Very good. Thank you. Those are frequently encountered values. I hope you guys remember the pi/6, pi/4, pi/3, that kind of values. Okay, that's it. Any questions so far? Okay, let's continue. Again, this looks complex. Cotangent, inverse cosine, square root of 3 over 3. But I always remember that inverse cosine gives you the angle. And this angle, let's say, is theta. So cosine theta is negative square root of 3 over 3. Just like what we draw here. So what is theta? Cosine theta is square root of 3 over 3. We don't know. We don't know what it is. But again, let's use the unit circle to figure that out. Okay, this is a negative value. Cosine of it should be in this, on the negative side of the axis, right? Inverse cosine should give you an angle in the second quadrant. Because we are doing with a negative value. It can only happen in the second quadrant. Inverse cosine's domain is just 0 to pi bracket. It can only take the first quadrant to the second quadrant. Only the second quadrant has the x value which is negative. So let's draw a triangle here in the second quadrant. Let's say this is angle. So if this side is square root of 3, the hypotenuse will become 3. What is the length of this side? We just draw imaginary triangle to help us figure out each side, then we can determine the values of that angle. So this side, let's say, is a. So a squared plus square root of 3 squared equal to 3 squared. So a squared plus 3 is 9. A squared is 6. A square root of 6. Is that correct? So we figure out the opposite side is square root of 6. Okay, we figure out all the sides already. We still don't know what this angle it is, but don't worry. We were not required to write what is the exact degree of that angle. Instead, we just calculate trigonometric functions of that angle. Cotangent this angle. The angle has a reference angle on this side. So the cotangent of that guy now should become easy. Cotangent of that guy is just adjacent side divided by the opposite side. Right? Adjacent side divided by the opposite side. Although we don't know what the angle it is, but we draw the triangle already. So we can infer what is cotangent theta from this triangle.
So would it just be the square root of 3 over square root of 6?
Very good. You get the cos. If you factor it, it will be square root of 3, square root of 3 times square root of 2. The 1 over square root of 2 is square root of 2 over 2. That's it. We still don't know what this angle is. But don't worry, as long as we figure out an imaginary triangle, finding the trigonometric functions of that angle is just there. Okay, anyone has any question? So now you see how helpful this imaginary triangle is.
So for that one, our overall answer would be square root of 2 over 2.
Yes,
Okay.
that's it. Let me draw a divided line. Okay, to summarize the general steps, what I have just done is first, write the theta in the original form. Second, determine which quadrant it is. Then draw the triangle. Lastly, do the calculation based on the new triangle. So after every class, I upload my lecture notes to the Canvas. But those are general steps we follow in our last question. When you are doing a complex one, those are general steps you should follow. First, we write the angle in the original form. Then we determine it is in the second quadrant. Then we draw the imaginary triangle. Lastly, we figure out each side of the triangle and determine the cotangent or the trigonometric functions according to this imaginary triangle. That's it. That's the 4 steps we follow. Okay, this is going to be the last question of today's class, since we only have a few minutes left before the quiz. And I think this one is also easy. Cosecant -1. Again, remember, this is just an angle. We don't know this angle is. How about cosecant this angle equal to -1? That's all we can know about this relationship. If we write it in the original form, it's just this original form. Cosecant theta equal to -1. How do we define the cosecant? It's 1 over sine. So 1 over sine theta is -1. In other words, sine theta is just -1, right? So think about it. We do not need to draw the imaginary triangle in this case, because this case is easier than this one. So what angle would satisfy such a relationship?
For -1, wouldn't it have to be 3 pi over 4? Or 3 pi over 2?
I'm afraid not. So if you don't know the trigonometric function values, as always, draw a unit circle, help you to think about it. Our inverse sine is defined on this side, right? From -pi over 2 to pi over 2, that's where we define our inverse sine. If you want to go back, you can only go back from here to here, because that's where the angle is. And again, sine theta corresponds to y value. So what kind of angle corresponds to the y value -1? It is here, right? So what is this angle?
3 pi over 2.
This is negative pi over 2.
Oh, sorry.
Thank you for trying. Yeah. This where it is defined and only on this side. And we need to figure out a terminal point which use y coordinate as -1. So the only possibility is this terminal point on the unit circle, and this point corresponding to an angle negative pi over 2. That's it. Okay, any question on this one? Let me draw a divide line so that you know which question is belong to which question. Okay, we still have this calculated part. We can talk this at the beginning of next class. This should be easy, just plug into the calculator. Okay, there's no difficulty here. All the hard part is on these lecture notes. And I think the definition, how we get the inverse functions, are the most difficult part of today's class. For those questions, try to follow the angle rule. Always think it as an angle. If it is simple, you can just rewrite everything in the original form and figure out the angle. However, there are cases where it is not so simple. So you just draw imaginary triangle on the coordinates to help you figure out the trigonometry functions. Okay, so we still have 2 minutes before the quiz. There are only 2 questions on the quiz. However, each question has different paths. So do not ignore any path. Do not forget any path. Again, please turn on your camera. Please turn on your camera. Share your whole screen. Share your whole screen. We're preparing for a quiz.